So before we talk about the new material, just like we did with the confidence intervals, y'all, I want to kind of have a conversation to remind you guys about just the basic logic behind doing what we call significance tests. All right, so let's go ahead and read this real quick. Mr. Brown wants Meister to see if the percentage of students who leave for study hall is higher than 40%. Which means essentially what we're going to do is start writing some hypotheses, okay? She takes a random sample of 50 students and finds that 23 leave for study hall. Okay, guys, what kind of variable is this? Categorical or quantitative?
Categorical.
Categorical?
Because they either leave or they don't. It's yes or no.
It's a yes or no question. And so, guys, as we're trying to decide this, even though I gave you numbers to summarize what was said, what was said was, do you leave for study hall or not? Okay? Is everybody with me? All right. So this is categorical. And what kinds of statistics should we use here? P hat. What is our P hat? It is not 23.
Right. 23 over 50.
It's 23 out of 50, which works out to be 0.46. All right. What's my null hypothesis going to be? First of all, what symbol is it going to be about?
Equal.
Well, it's going to have an equal sign. What is equal, though? All right. Do we need to write a hypothesis about P hat? Hint. We know what P hat is, yes? So is our hypothesis going to be about P hat?
No.
No. It's about...
Taylor, was that your class measuring on Friday?
It's probably my tape measure.
I'm going to leave it here just in case, okay.
But I don't think it was my class on Friday. It was on the block days that we were using stuff, and we were using a much larger measuring tape than that one. But I do vaguely remember somebody borrowing one of those from me, so I'm going to assume it was mine.
All right.
I can't even remember who borrowed it. Okay. All right. So the whole idea is we know the value for P hat. What we're questioning is the value of P. Okay? And what is our hypothesized value for the proportion? And here's a hint. It is not P hat. You want to know how I know it's not P hat? Because P hat's from a sample. What do we know about samples?
They are not perfect.
They're not perfect. We're just trying to decide, is it higher than 40% or not? So it's going to be P equals 0.4. My alternative would be P is greater than 0.4. There's two ways we know that. The first of which is my P hat is bigger than 0.4. We're just trying to decide, is it big enough that it's meaningful? Okay? Also, we're trying to decide, is it higher than 40%? Higher than and greater than pretty much mean the same thing in this context, yes? Okay. So far, is everybody feeling okay? All right. All right, let's talk about normality. And P and 1 minus P both have to be greater than or equal to 10. And you use the P from your null hypothesis. Okay? So it is going to be 50 times 0.4 and 50 times 0.6. I think it's 20 and 30. Are 20 and 30 both bigger than 10? Cool.
Okay, sometimes I get slightly confused. When do you use 10 and when do you use 30?
Means versus proportions. So that's literally why we go through this piece and this piece. Okay? So when it's a mean, or when it's a p, for p hats and p, you use the np and 1 minus p. Okay?
When it's not.
When it's x bars and mu, you use n greater than or equal to 30.
Okay.
Or you know you're sampling from a normal population. Everybody okay? And our hypotheses, we already wrote them, but our p equals 0.4, and then p is greater than 0.4. All right. All right. So now our test statistic, this is proportion, so it's a z. And what we did, y'all, was we did p hat minus the p from the null hypothesis. We divided by the square root of the standard deviation formula on the null hypothesis, okay? So what that would look like here. Well, our value for p hat was 0.46. What's our p from the null hypothesis? Zero 0.4. And then we do the square root of 0.4, 0.6 over 50. I don't know what that works out to be. I'll need some help with that.
Yep, 0.86. P 0.87, no, since there's a 6 after a 6. Yes.
How about 866?
Yeah.
All right. Then what? Do you guys remember how to do the p-value?
Is it normal CDF?
It is normal CDF. And what we do, since we use that test statistic. So we use 0 and 1 as our mean and standard deviation because we're talking about z-scores. And we find the area to the right of 0.866.
If we were trying to find like less than or lower than 40%, would it be too low?
Mm-hmm. However, like if your sample was 0.46 and you're trying to test, is it less than 40%? Your sample gives pretty crummy evidence of that. What are we getting? I bet it's a really high p-value. Not like really high, but
I have 0.15.
yeah. Not an insignificant, or not a significant p-value, right? All right, now I want to kind of talk to you guys about what does that value really mean, okay? What is that? It is basically saying if the actual percentage is in fact 40%, the likelihood of getting a sample of 46% is about 0.19, which is a 1 in 5 shot. Now, could that happen by chance? Well, 1 in 5 shot is relatively likely. Okay? So if that could happen by chance alone, which 1 in 5 is likely enough that it could happen by chance alone, is that 46% big because it's actually more than 40%, or is that 46% big because of chance? And the answer is we don't know. So we have two hypotheses. We can't rule out chance. If I can't rule out chance, in other words, I can't rule out my null hypothesis. How many hypotheses I got? 2. So do I know which one is true? No. All right, so you're going to say, since our sample is reasonably likely.
And that's when it's higher than 0.1, right?
We usually use 0.05.